Right. All right. Am I audible? Hello, everyone. Good afternoon. I hope you have solved the questions and some problems of the previous chapter that we have completed the last class. Did you? Next one. Did you solve questions? Okay, so today we'll be starting with a new chapter, that is motion in a straight line, and we'll be just dealing with it, covering each and every concept with the problems. What you have to do, you have to revise the things and come. Okay, and I need every one of you to solve problems with me right here. Okay, I'll be just discussing few topics and then we'll be solving more of the questions. We'll be focusing more on the questions because that is more important.
Okay, sir.
Okay, right. So please revise the things at home and come in the next class and solve questions. Without solving questions, you won't be getting the concepts. Right. So let us start with it. So basically, when we start with the motion, see, physics is divided basically in two parts, that is kinematics and dynamics. Kinematics, and another one is dynamics. What is kinematics and dynamics? So basically, dynamics is where we study the cause of the motion. And here we study the properties of the motion, like what is the velocity, what is the acceleration, how much distance, how much displacement is there. So that we study in kinematics. In dynamics, we study how that motion occurred, who created that motion, Who provided that force that the body went into the motion? Understood the difference? Yes or no? Right. It is study of cause of motion. Okay. A study of motion without considering the cause. Okay. So next term that we comes into the picture is distance and displacement. Distance and displacement.
Excuse me, sir.
Yeah, go on.
Sir, can you zoom in a little bit, sir?
Zoom in.
Yes, sir.
Is it fine?
Yes, sir. Thank you, sir.
All right. Okay. So what is distance and what is displacement? Before that, I have to explain you rest and motion. Rest and motion. See, rest and motion. If a body changes position, changes its position with respect to surrounding, with respect to surrounding, with passage of time. Sorry, it's supposed to be motion. Similarly, if a body does not changes its position, and copy the same here, it is in motion. So these things are basic. Please be quiet, everyone. Focus here. These things are basic. Okay, these things you know, and you have been studying these things since class 6. Okay, so basically, when a body is said to be at rest, when, for example, it is not changing the position with respect to any object. For example, if a boy is standing near the tree, if a boy is standing near the tree and time passes by, t is equals to 1 hour, 2 hours, 3 hours, 4 hours, and the boy is not changing the position with respect to the tree because I have considered the tree as frame of reference. So the boy will be said to be at rest. And if it changes its position at 4th hour, let us say he is here. Okay, so he'll be said to be in rest, as in motion. Okay, so it goes like that. Either it is in rest if it is not changing its position, or if it is changing its position, so it is said to be in motion. Okay, but one thing, rest and motion are like relative term. They are not absolute term. This body, which you said to be at rest, may not be at rest. Okay, that may not be at rest. That depends. Who is observing him? Okay, it depends on who is observing him. For example, if I show you, this is the earth. Okay, this is the earth, right? On earth we have a road. This is the road, and on the road we have a bus. In the bus we have people. This is person A. Let me draw it a bigger. Person A is in the bus. Person B is in the bus. Person C is standing here, and person D is in the space. Okay, person D is in the space, outer space. All right, and the bus is moving. A and B are sleeping in the bus. Okay, A and B are sleeping in the bus, and C is sleeping outside in the lawn, garden. We could not hear it. Is there any problem?
No, sir. No problem, sir.
Okay. So now tell me, if A is the observer, A is observing. So if A is observing, will A say that B is at rest or in motion?
Rest, sir.
Rest. And what will be the comment of A on C? What will A say about C?
Motion, sir.
Motion. Okay. And what will D say about C?
Rest, sir.
No. D is in outer space. And for outer space, Earth is constantly rotating, isn't it? So he will see this. The person D will say that C is also rotating. Actually, the thing that happened now, whoever is the observer, his motion, his considerations, his time of reference, everything is considered to be zero. Even if it is he is moving, for example, if I say that I am moving with the speed of 40 meters per second, okay, and you are standing here. So if I am the observer, and this is Yashwant, so I will not say that I am going forward. I say that Yashwant is going backwards with 40 meters per second, because that's what I will see. I will
Yes,
find myself as rest. Okay, that is the tendency of observer. Whoever is the observer, he is at rest. And with respect to him, we calculate the other motion, the properties of motion, whether he is at rest or in motion.
Yes, sir.
Okay. If I am going this way, 40 meters per second. So I'll say that Yashwant is going this way 40 meters per second,
Forward, sir.
because I saw that Yashwant just passed by. This I saw. So that's why I'll say like this, that Yashwant moved by. I did not move forward. Because whoever is the observer, his motion is considered to be zero. Whatever his motion is, we'll consider it to be zero. For example, one more thing. If I am moving with 40 meters per second this way, and Yashwant also is moving in the same direction with 30 meters per second. So what will I say that if my 40 meters per second is zero, that means Yashwant is moving backward with 10 meters per second. And in reality, what will happen? I will take over Yashwant. With a net speed of 10 meters per second. Yes or no?
Yes, sir.
Yes or no? The relative
Yes,
speed
sir.
between me and Yashwant will be what? 10 meters per second, because
10
he is
meters per
30,
second.
I am 40. So I'll be moving forward the 10 meters per second more than what Yashwant is moving. So I'll be taking him over. So what I will see that Yashwant is going backward with 10 meters per second. That's what happened.
Yes, sir.
That's what you say also. Whenever you sit in a train and you see something, so what do you say that? I passed over a tree or the tree passed by? What do you say?
The tree passed
The
by.
tree
We
passed
say,
by.
sir.
Exactly. That's what you say. Because you consider yourself to be at rest.
Yes, sir.
Yes or no?
Yes, sir.
This is what happens there. This is the reality of physics. Right?
Okay, sir. Yes, sir.
Now, these are just to make you understand. I hope you have understood this term. This relative, rest and motion are relative terms, not absolute terms. Because this depends on the frame of reference. Who is observing? Right?
Yes, sir. Can
Now,
you move to the before slide?
this slide.
Yes, sir.
Okay, write it fast.
Yes,
You
sir.
have been provided with the videos now, isn't it? Have you been provided with the recorded lectures?
No, sir.
No.
Yes, sir.
I was told that you are provided with the recorded lectures. Huh?
Sir, we are not being provided, sir.
Okay.
Sir, we didn't got the videos, sir. We have not got the videos.
Okay. I'll see about it.
Okay, sir.
Did you get any kind of online portal where you submit your assignments and all?
No, sir.
Okay then. Actually, we have just got one class for physics, and one class is really not enough to complete the whole section of physics of class 11 in a week. So we'll be moving quite faster, but I'll be trying to explain everything to you. All right.
Okay, sir.
So please focus here in the 1 hour class and write everything fastly, as fast as you can. And revise the things at home. You don't revise at all. And I hope that you are understanding my way of teaching. Are you fine with it? Hello. Am I audible?
Yes, sir.
Okay. Done. Shall we move forward?
Yes, sir.
All right. The next that we have to see is about distance and displacement. What is distance and what is displacement? Okay. Distance is the actual, if I describe it, actual length of path traveled by the object or body, whatever you say. Okay, this is distance. And it is the change in position. It's a change in position of an object in a fixed direction. Okay, in a fixed direction. Or it is the shortest distance between initial and final points. Now, what is distance and what is distance? For example, a boy lives here, okay, and he plays football. This is the stadium where he goes every day, and this is the path. This is the road through his house. So what he do? He goes from here. What he does? He starts his journey from here, take a right turn, and end up here. Agree? Agree? So let us say that this is L, this is distance A, this distance is A, and this length is L, right? So what actual length he traveled? So what is the distance here? Distance will be, I'm marking the points. This is point A, this is point B, and this is point C. So distance is AB plus BC. This is actually what he traveled, L plus A. Okay. And what does displacement signifies? So this is the displacement there. Shortest distance between the initial and final point is the straight line between them. If you draw the straight line between the initial and final point, that is the shortest distance that you can get. So shortly, he can travel like this also. Okay. So displacement will be AC. And that is by Pythagoras is under root L square plus A square. Do you agree with this? Yes or no? Do you agree with this? Put your thumbs up if you agree with this. Right. So this is the difference between distance and displacement. Distance is the actual length of path traveled, and displacement is the change in position of an object between initial and final point. One more thing, distance is a scalar quantity. Scalar quantity. Scalar quantity means what? What do you understand by scalar quantity? Scalar and vector, do you know this? Do you know this? Scalar and vector quantities?
Yes, sir.
Right. So scalar quantities means what? It just need the magnitude, no direction. You just need the magnitude. While displacement requires magnitude plus direction. Displacement requires magnitude plus direction. To get it specified, you need to tell both. For example, if you are here at position A, you are blindfolded, and I am standing in front of you, okay, and your friend is standing here. So if I say that your friend B is 5 meters away from you, will you be able to catch him? Will you be able to catch him? You are blindfolded and I say that your friend is 5 meters away from you. Will you be able to catch him or her?
Yes, sir.
No. But if I say that he is 5 meters towards the east from you, now will you be able to catch him?
Yes, sir.
So that is what? Distance, magnitude, and direction. 5 meter east. So this specifies the magnitude. And this specifies the direction. Both are required. Both are required to specify displacement. Okay. Write it down fast. Tell me when it is done.
Completed, sir.
Right. Completed? Right. Okay. So try to solve a question. Try to solve a question. Question says that this is a circular park. Okay, the footpath in the park is circular. A boy starts from point A. Okay, let me draw it more perfect. Right. So this is a circular park. Okay. The boy starts from point A through point B, point C, and reaches point D. He starts from A, B, C, and reaches point D, and he stops here. So you have to find ratio of distance to displacement. Try to solve this. And the radius of this is R. Radius is given, that is R. Try to solve this, everyone. 2 minutes you have. Is it done? Is it done? Yes or no? Yeah. I could not hear that. I could not hear that. Please tell with the mic. I could not hear that. Please tell with the mic. Okay, I'm solving here. You just match. Whoever has solved, you just match it, whether it is matching to you or not. So see here, what is the distance first? Distance. Distance is the actual length traveled. So can I say that he traveled 3/4 of a circle? So 3/4 of whole circle is 2 pi r. Yes or no? Put a thumbs up if you agree with this. Right. So it will be, if you cancel this out, it will be 1.5 pi r. Okay, it will be 1.5 pi r. Right. And what is the displacement? Displacement is the straight line. Displacement is the straight line between initial and final point. So this will be the displacement. If I mark this point O, so displacement I can find it as under root of AO square plus OD square. So that will be under root of R square plus R square. That will be root 2 times R. So ratio will be distance to displacement. Distance is 1.5 pi R divided by root 2 R. So it will be 1.5 by root 2 into pi. This is the answer. Did you get the same thing? Did you get the same thing? Yes or no? Did you understand this? Put your thumbs up. Everybody. Any doubt? All right. Write it down quickly and tell me when it is done. Such questions may be asked. Is it done? Say yes or no. No, sir. Okay. Do it fast. Is it done?
Yes, sir.
Yes,
Right.
sir.
Okay. Now see here, we have two terms, speed and velocity. It is rate of change of distance. What do you mean by rate of change of distance? And this is rate of change of displacement. I'll explain it. See it. So speed is distance upon time. Distance upon time in simple words, and velocity is displacement upon time. Displacement upon time. Similarly, speed is a scalar quantity and velocity is a vector quantity. Right? So rate of change means what? Whenever we write rate of change means change with respect to time. So rate of change of displacement means displacement change with respect to time. Rate of change of distance means distance change with respect to time. Okay, so that is speed and that is velocity. Speed is in any direction, velocity is in a specific direction. Okay, and one more thing, if you are moving in a straight line, so let us say that distance from here A point to B point is this only, and same is the displacement because this is a straight line. So in that case, in straight line, in a rectilinear motion in a straight line, rectilinear motion, that is motion in a straight line, speed is equals to velocity, because there as distance is equals to displacement. As distance is equals to displacement. Understood, everyone? These are simple terms. These you already know. That's why I'm not focusing more on them. Do you agree with this?
Yes, sir.
Tell me when it is done. Now see, there is something called average velocity. Average velocity. Now see one more thing. Speed and distance is something that we really can't measure actually. Speed and distance is something that we actually can't measure. Because let us say that a body started from point A and ended at point B. We have three equations of motion. Okay, that will tell you later. So the speed is this, the distance is this. We cannot measure, we cannot find the tendency of the body, but that where will it be moving, how much curve it will be taking, how much distance will it be traveling. Okay, but if we know the initial velocity, we know the final velocity, we know the time, we can calculate many things if it is displacement, because that is in a straight line. And the tendency we know, tendency of the body we know, because if the body is in a straight line, its velocity may be constant if it is not accelerating. If it is accelerating, so the acceleration will be constant. But in case of curves, if he's taking lots of curves, he has to stop here, he has to slow down here, he has to move fast here. So this is really difficult to calculate the distance of any object. That is based on the tendency of that particular man only, right? But in case of displacement, we can calculate the displacement through given formulas. Now, whenever I'll be taking the words velocity or speed, I'll be considering it to be same. Okay, and even in the books, sometimes they say you to calculate the speed, but they consider that the body is moving in a straight line, so speed is equals to velocity. So don't get confused. Actual speed we cannot calculate because that is based on the tendency of that particular man. Where will it be moving? How much distance will he be traveling? So distance is something that depends on the tendency of man who is driving. But displacement is constant in all of the cases because it is a straight line between initial and final points, and that we can calculate. So average velocity comes into picture when it is total distance traveled. Total distance traveled by total time taken. Because what happens sometimes, whenever you go from your house to any destination, sometimes you accelerate, sometimes you move with a constant velocity, sometimes you have to de-accelerate, you have to apply brakes if something comes in front of you. Whenever you see the traffic, so you have to de-accelerate there. Okay, so velocity of that particular object that is moving is not constant throughout. Okay, you cannot move with a constant velocity throughout the motion. Do you agree with this? Do you agree with this?
Yes, sir.
Good. So in that case, we calculate what was the average velocity. For example, when you start traveling from your home to, let us say, some other city, and you say that you took 6 hours to reach there. Okay, total distance was, let us say, 120 kilometers. 120 kilometers was total distance, and total hours was 6 hours. So what is the velocity? So velocity is 120 by 6, that is 20 meter per second, or 120 kilometer per hour. Sorry, this kilometers, and this is hour. So total velocity is how much? 120 kilometer, 20 kilometer per hour. So that doesn't mean that you moved with 20 kilometer per hour throughout. Sometimes you stop, sometimes you were with more of the velocity, sometimes you were with less of the velocity. But we say that averagely we traveled for 20 kilometer per hour for the 6 hours to reach the other city. Do you agree with this? So that's
Yes.
when this average velocity comes into picture, and that is really important. So average velocity is not total distance traveled by total time taken. But there is one more term called instant velocity, instantaneous velocity. Instantaneous velocity. This is the velocity at a particular instant. Velocity at a particular instant of time. That means, okay, you started traveling with 20 kilometer per hour and you reached in 6 hours. Okay, but sometimes your velocity may have varied. You must have stopped, you must have accelerated, whatever had happened. So what was the velocity at, let us say, that 4th hour of your journey? What was the velocity at, let us say, 2.5 hours of your journey? So at that particular time, you must be giving just one answer, like at that particular moment, I was moving with 45 kilometers per hour. So that is called instantaneous velocity. Understood?
Yes, sir.
Good. Now write it down.
Okay, sir.
Write it down. Write it down. Is it done? Is it done? Tell
Yes,
me if
sir.
it is done. Okay. Now I have a question for you.
Sir, 2 minutes, sir. 2 minutes, sir.
Okay, do it fast.
Okay, sir.
Is it done yet? Isn't it done yet?
Yes, sir. Done, sir.
Okay. Now the question goes like, a cyclist moves on a circular track. On a circular track of radius 100 meters, completes one revolution in 4 minutes. Calculate average speed, average velocity. That is all this. Please be fast. Do it fast. I need the answer this time.
Sir,
Go on.
sir, 2.5 meter per second.
Speed is 2.5 meter per second. No.
Okay, sir.
Two point five is the wrong answer. Shall I do it? Shall I do it?
Yes, sir.
Okay, see here. So what is average velocity? Sorry, average speed first. What is average speed?
Total distance by total time.
Exactly. Total distance by total time.
Time.
Okay. And what is total distance? He traveled a circular track. Okay. Radius is 100 meters. So he completed one revolution means what? From the
2
point
pi
he
r.
started, he ended there itself. Okay. Starting and
Yes.
ending point was same. He started and ended then and there itself. So total distance was 2 into pi into r, that is 100.
R.
Total time
Yes,
we
sir.
take in seconds. Time is generally taken into seconds. So 4 minutes into 60 seconds. Agree or not?
240. Yes, sir.
Okay. So now this will be 200 pi by, this is how much? 240.
240, sir.
So this will be 4 5s are 4 6s are 5 by 6 pi meter per second. Okay. Now what is the average velocity? It will be total displacement by total time. How much displacement occurred? Tell me.
0.
How much was the displacement? This zero was the displacement because there was no net difference between the initial and final point. So 0 by 4 into 60, that is 0. 0 meter per second is the average velocity.
Yes, sir.
Understood?
Yes, sir.
Write it down. Written?
Sir, not yet, sir. Completed, sir.
Done? Right.
Yes, sir.
Last topic for today. We'll be calculating the average velocity. See, average velocity is calculated. Average velocity will be calculating. Condition number 1. What happens? Let us say that this is the distance displacement done by a body A and B, and it is divided into 2 half times. This is T and this is T. Okay, and they say us that for the first half time, or we can directly do it. Let us say the total time was T, or let it be. So the first half time, the velocity was v1. For the first half time, the velocity was v1. For the second half time, the velocity was v2. Okay, so now they are asking to calculate the average velocity. Okay, will be going through the same way. One more thing, we have not been provided with the displacement. We don't know how much displacement occurred, that is S1 for this first half and S2 for the second half. That we don't know. This data we don't know. So what is average velocity? Average velocity is total displacement by total time. Okay, total displacement by total time. And what is total displacement? Isn't it S1 plus S2? And what is total time? T plus T?
T plus T. Sir.
Yes or no?
Yes, sir.
Agree? Right.
Yes, sir.
But S1 plus S2 we don't know. S1 plus S2 we don't know. Can we calculate this distance S1? We know V1, we know T. So isn't V1 S1 by T? So S1 will be V1 times T. Yes
Sir.
or no?
Sir.
Right? Similarly, S2, V2 times T. Yes or no?
Yes, sir.
Right? So can I replace it here? S1 as V1T plus S2 as V2T by 2T.
Yes, sir.
Right? So it will be, I'm taking T as common, V1 plus V2 by 2T, and this T will cancel. So V average will be what? V1 plus V2 by 2. You can directly remember it. You can directly remember it. Okay. So you will say, sir, what will be the second case then? You just wait for the second case, then you write it down. Second case says that the body traveled the same displacement, A and B. But now what we know is the velocity for the first half is V1, for the second half was velocity V2. And we know the displacement is, now we have divided into two half displacements. Okay, earlier it was two half times. Earlier we used to know the time, first half time, second half time. Let us say that total journey was 1 hour. So this was 0.5 hour and this was 0.5 hour. Now let us say that total journey was 100 meters. So this is 50 meters, this is 50 meters. But we don't know that how much time it took to cover the first 50 meters and how much time it took to cover the second 50 meters. And they may vary. You should not say that, sir, if it is equal distance, the time will also be same. It is not like that. It is like that if you move fast for the first half, so you'll cover the first half in smaller time. If you move slow for the second half, you'll cover it in the larger time. So you got to know that if you are moving with the same distance and different velocity, so time will not be same. Yes, agree? Yes or no?
Yes, sir.
Right. So V average I'm writing here, V1 plus V2 upon 2. Now here. So here what we know, again average velocity is what? V average is what? V average is what? Total distance S plus S by total time T1 plus T2. Now this T1 and T2 we don't know. This we don't know. So we'll calculate this again. V1 is S by T1. So T1 will be S by V1. And similarly T2 will be S by V2. S by V2. So if I substitute it here, S plus S by S by V1 plus S by V2. So it is 2S. I'm taking S common. One by V1 plus 1 by V2. So SS cancel. If I take 1 V2, it will be 2 V1. Understood this? Did you understand this?
Yes, sir.
Okay. So that's what I'm saying. That's what I'm saying. 1 minute. That's what I'm saying. That when we know the time, when the journey is divided into two half times, then the average velocity is V1 plus V2 by 2. And when the journey is divided into two half distance, then the average velocity is 2 V1 V2 by V1 plus V2. You can remember it directly. They can ask the question like this. They can ask the question like, if the body travels with 20 kilometer per hour for the first half distance and then 40 kilometer per hour for the second half distance, so what is the average velocity? So the body traveled for two half distances, so average velocity will be 2 into v1 v2 by v1 plus v2, like that. Understood or not?
Understood, sir.
Say yes, sir. Good. Write it down, and that's all for today. And please revise and come from the next class. This is very important.
Okay, sir.
And solve questions also. Is it done? Shall I stop sharing?
So no, sir. Wait for some. They're copying, sir.
Okay. Is it done?
Yes, sir.
Okay then. Thank you. Bye.